Hello, everyone. My name is Gitika Gorthy, and today I'm very honored to be interviewing a very special space champion, Dr. Kurt Anderson. Dr. Anderson is the Associate Dean for Undergraduate Studies at RPI and Professor of Aerospace Engineering and Mechanics. Professor Anderson's primary research goals are associated with development of advanced algorithms for modeling, simulating, and analyzing the behavior of complex dynamic systems. Examples of such systems include, but are not limited to, molecular dynamic systems, spacecraft, robotic systems, automotive applications, the human body, and manufacturing operations. I'm so excited to learn more about Professor Anderson's research in Computational Dynamics Laboratory at RPI and journey from a young child, graduate from Stanford University's Ph.D. program, to a professor and scientist in the space industry. Welcome, Dr. Anderson. Thank you so much for taking some time out of your busy schedule to conduct this interview.
Thank you very much for inviting me. My pleasure.
Yeah, before we get into understanding what really intrigued you and got you into the space industry, first I'd like to know more about your typical day. What do you currently do and how does it run?
Well, unfortunately, since I became associate dean, which is almost 12 years ago now, my days are a little less interesting because much of my time, the majority of my time, is actually spent doing things that keeps the school running, as opposed to my research and my teaching, which is what I'd rather be doing. So I do, in fact, what I was doing in the minutes before this interview, and I've got it up on my computer in front of me, my screen right over here, is I was working on a control algorithm for the control of a small spacecraft. And I was writing up a control algorithm for my spacecraft senior design course that I teach. And I was adding another example of how you would use a more advanced control, and then they could compare that with the three other examples that I've already written. And so that's the stuff I'd much rather do rather than the administrative stuff. So 70% of my time is spent doing administrative stuff, and the other 30% of my time is teaching and research and managing my graduate students.
Yeah, so to focus on the 30% where it's all about the fun stuff you like to do, I also read how you work at, or you're in the Computational Dynamics Laboratory at RPI. So could you explain some of the work and research you do there?
So the Computational Dynamics Laboratory is a laboratory that I built,
Oh,
and it is associated with how do you model accurately realistic dynamic systems. And so a dynamic system is, think of anything that F is equal ma applies to, which is most everything, Newton's second law. But these systems become very complex in reality. If you talk about the human body, you could model this joint is connected to this joint, connected to this joint. So the human body is a multi-body system with effectively an infinite number of degrees of freedom. How does one model that so one can predict very accurately how the body would behave in space or in an accident or even running up the stairs, and solve those equations and make predictions quickly, and I mean quick enough that you can use them in an engineering sense. So we might be able to do it, or we can run the simulation and get a result out in a month. That's not quick enough. We need the result in minutes, not months. And so this problem, specifically developing advanced algorithms that allow us to compute and do these simulations and make these predictions more accurately, is what I've been working on for about 40 years now. I mean, as an example, you mentioned one of the things I work on is molecular dynamics. I didn't originally do molecular dynamics, but Sandia National Laboratories approached me because you may or may not be aware that a number of the most powerful computers in the world are resident at Sandia National Laboratories for a variety of reasons. And they were trying to model the behavior of a particular enzyme called ribosome, which is instrumental to photosynthesis. The idea being is, oh, you may or may not be aware that photosynthesis is a very robust process, but it's extremely inefficient. Photosynthesis at its best is less than 2% efficient. So if they could figure out a way to improve photosynthesis in plants to get it just from 2% to 3%, that doesn't sound like much of a difference, but effectively, you've just increased the yield of an acre of crops by 50%.
Wow.
So they used totally correct methods, and threw one of the two most powerful computers at the time in the world at it. And after a month of running nonstop, they had gotten, they figure, less than 1,000th the way through the simulation they wanted to do. Okay, we can't rely on computing power, even though what we're doing is correct and it's accurate. At the rate we're going, it's going to take us decades, centuries to do this problem. So they approached me on how we could use some of the methods I developed for spacecraft and other things. So we might be able to solve the same system, no more accurately, but do it many thousands of times faster. And so the first thing we tried with me working with them showed immediate speed up of 50 times, which still isn't fast enough. But we were eventually able to do the same simulation and effectively get the same result that it took them a month on one of their supercomputers to do. We were able to do in our lab in 15 minutes.
Wow.
And so it's
Crazy.
the algorithms, though, are extremely difficult to understand because they're algorithms that are optimized the way a computer would solve the problem, not the way you and I would solve the problem. And so you have to start thinking about not how you and I would solve the problem, but how the computer actually does it, or how the computer should actually do it. And again, the equations become very complex, but in some regards, much simpler for the computer. And so this is what I've been working on for many, 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 many years, but this grew out of my work in the defense sector and for the International Space Station, that I built some of the original models for the International Space Station back when it only existed on paper. And we were trying to figure out how to control it adequately so that it didn't rip itself to pieces when they started building it, where the different control systems start fighting each other. And I've been
Wow,
doing it ever since.
yeah, that sounds like amazing research. I mean, a lot of people, I feel like, a lot of young students don't realize the interdisciplinary in studies, especially, the importance of like computer science in different areas of studies, like especially science, like you were saying about plants. And so I think, that is really crazy to think how the program that you guys were able to develop was like only 15 minutes, while some of the best computers at the time took like very long. So that's
Months.
great. Yeah, months. And so that's like amazing. And to see the power is just really cool.
Yeah. So it's a problem that many people have is they think, oh, computers are so fast and they keep on getting faster, we'll be able to do anything. Well, no, the difficulty with solving many mathematical problems does not grow linearly with the apparent complexity of the problem. The complexity or the difficulty actually grows geometrically, or even some cases exponentially. And so you can quickly overwhelm even the most powerful computers using traditional methods. And so actually, the greater advances in computing speed have been made through improved math and improved algorithms, more so than improved computer power. Little known detail, but it's absolutely the truth.
Yeah, and
Because as we become more fluent with computers, we, the engineers and the scientists, are getting better at writing algorithms to work on those computers.
yeah, I think that's like a really good point. And the way you explained it was actually like it just changes your perspective on the way you think, like what things need to be improved on, what things need to be explained better. So that definitely makes sense. And I'm assuming that's the most exciting project you've worked on. If not, what is the most exciting project or research that you have or currently working on?
Oh boy, that's a tough one.
Yes.
Some of the most exciting stuff that I ever did, I really can't talk about because I was in the defense sector at the time.
Okay. Hmm.
Um, what was exciting about that was simply the level of technology was just beyond belief. It was just amazing what we were able to do. Um, and we did it, and you were successful, and it worked,
Yeah.
and it just is an amazing feeling when you think of something that's original and difficult, and you work on it and you build it and you test it, and then you actually put it in space and it works just the way it's supposed to. uh, that's really a fabulous feeling. And so I sort of miss that nowadays because I don't get to work on the hardware. I don't get to actually build satellites and run the tests and design the tests the way I used to. So that part I miss. But in some regards, what I'm working on right now is amongst the most exciting things I've ever done. And that's something that's called OSCAR. And it stands for obsolete spacecraft capture and removal. And effectively, it's a satellite system for finding, capturing, and deorbiting space junk, space debris, which is becoming a huge problem. And so that's something that I and my students have been working on for about 6 or 7 years now.
That's amazing. Yeah, and I feel like this is always a tough question for everyone because every project you work on is exciting and amazing in its own way. But definitely what you were saying is like the difficulty level, but seeing whatever difficult idea you had come to life is one of the best experiences. So I'm glad that you were able to have those special moments in your life. And another part of space that I really enjoy is how it's a very global community. Like space, every single country, in the majority of the world is very involved. And so being invited to Germany for a 2-year period as a visiting scholar and researcher, I'm sure there's very difference, like a huge difference between how the space system works here in the US compared to Germany. So what were your experiences there?
They are quite different. Um, so a little bit of history. I was spent 2 years at Darmstadt. The significance of Darmstadt is, at least at the time, the European Space Agency headquarters were in Darmstadt.
Okay.
So you had the Technische Hochschule, the technical university there, which was one of the top technical universities in the German-speaking countries. And then you had their high energy physics laboratory, GESA, and then you had the European Space Agency. And so um, I spent time effectively doing with an appointment there as a visiting scientist and scholar, doing work on computational dynamics and some space work. And indeed, it was during that time that I was introduced to the space debris problem by a Swiss mathematician at the European Space Agency who was working on trying to better our understanding of tracking, finding space debris. And for instance, it was recognized as a big and growing problem by the European Space Agency, and they were putting significant resources into it then. It's only more recently been viewed as a problem by the Americans. Unfortunately, some countries are a little less environment minded when it comes to space than others. Um, and so we are now involved, but we're still not putting quite as much effort into it as the Europeans are. Um, there are other countries that are putting effectively no effort into it whatsoever. I mean, the majority of space, a huge fraction of the space debris that's up there was, everybody's contributed, but the sheer volume that was contributed by the former Soviet Union is just beyond belief. And that creates whole other issues because a lot of these objects are rocket bodies that still contain propellant. And so if they get hit by another object and rupture, they're going to explode and blow debris all over everywhere. So they're a nightmare scenario.
Yeah.
Uh,
And I, what was funny is I was talking with Mr. Jim Cantrell the other day, and he was saying how when he worked in Russia, he was noticing how the procedures for building the same thing you would build here in the US were completely different. So, not only the and problems they want to tackle or the missions they want to do, but also the structural way of developing the same exact product at the
it's
end is very different.
it's very different. And that was probably one of the best things, my 2 years in Germany were very good for me because I learned from them that they had some truly outstanding engineers and scientists, and they do things differently than we do. And I also made great friends and met my wife over there. So it was a wonderful experience in many regards. But it is a mistake for anybody that thinks, oh, yeah, well, we did it in America and we do it the best way.
Yeah.
No, we may do it a very good way, but it's arrogant to not think that you should at least look at how everybody else is doing it, because you'll probably discover whoever they are, they're doing some things better and some things worse. And, try to learn from what others are doing and follow the best practices. Uh, so that was quite an experience. ESA is not NASA, and
Yeah.
NASA certainly isn't ESA. And again, the education system and the way the scientists generally operate is a little bit different. But you discover that if you're a good scientist, you can pretty much operate in both camps, but you need to adjust your way of thinking. Uh, I had a time where I spent a couple of weeks in India working with a group. And what was interesting there, even more so than when I was in Germany, is what I thought was the problem and what my colleagues thought was the problem were different things. We thought other things should have been higher on the priority list and vice versa. And so it was interesting, coming to the understanding as to what the final priorities ought to be and how we ought to address them.
Yeah, it just really changes your perspective on how different
Yeah.
people think and how you can take that into consideration in the future. So I think a broad experience is always amazing.
Yep, absolutely.
Yeah, and I'm curious, did you always imagine yourself, think of yourself as when you were young, did you always imagine yourself to be where you are today, or did you have some twists and turns in your journey?
Oh, not at all. I mean, there are some people that know exactly what they want to do and they go out and do it. And I'll say my son as an example. He always wanted to be a vet, and he's going to vet school to become a veterinarian. And so it's just
That's awesome.
straight line, knew what he wanted to do. And me, I thought I wanted to do one thing, and it didn't work out. I could get into the details. I originally wanted to, I'm sorry, be a Navy fighter pilot. Couldn't pass the physical. The Navy was interested, but in my day, LASIX didn't exist. And there was something experimental called radial keratotomy, but if you did it, you were automatically disqualified from the system because they didn't know how long it lasted or how it would react in a high G environment. So I couldn't become a fighter pilot. Well, I loved anthropology. I couldn't do all the reading because I'm dyslexic. So I became an engineer, not because I loved engineering, but because it was easier, because engineers don't do so much reading, you do a lot of math. Well, I happen to be good at math too. So my path was really twisted, but it all worked out. And I discovered that I enjoyed engineering, but I hadn't planned on being an engineer. And I discovered I liked aerospace engineering. I originally had not planned on being an aerospace engineer. I mean, the reason I became an aerospace engineer was quite literally, I was sitting in a class and my favorite professor ever came up to me and said, how would you like to have a job working in aerospace this summer? I was actually a mechanical engineer. I wasn't an aerospace engineer. And I said, oh, that would be terrific. I'd love it. I took the job and I'm still working in aerospace engineering 40 years later now. And so you sometimes you know what you want to do, and other times opportunity presents itself. And all I can say is, if opportunity presents itself, please try taking advantage of the opportunity.
Yeah, yeah, and a part of the organization I founded, Ignited Thinkers, was to create those opportunities for students because I was always interested in space as a young child. However, I never knew like it was a real career, like attainable, something that I could do. But in middle school, because of my teacher who started a rocketry club, the first rocketry club we had in our school, and because I accidentally happened to join it, I got into space again. And so without that, I probably would have been on a completely different track. So knowing it just like being accepting to change, new ideas, new topics, and not shutting any doors down, but also providing these opportunities for others is just amazing. I'm so glad that professor offered you that opportunity because now you
Yeah.
find what you love to do. Yeah. And so, were there any obstacles in actually when you entered aeronautical engineering, like maybe finding jobs? Were there obstacles when doing that?
Um, there's always obstacles, but I was lucky. Um, I never had a problem finding a job. Sometimes the job market is somewhat cyclical. So sometimes it's easier than others, and sometimes it's very, very hard. Uh, it just happened that I was always able to secure a job and a good one. And so I didn't have to deal with that problem. So I consider myself lucky. Um, as I said, the biggest obstacle I ever had in some regards was probably a good thing. If I was going and testing nowadays, I would be indicated that I quote unquote have a learning difficulty. It didn't exist, that type of thing wasn't tracked or done in my day. And so I just simply had to deal with it. And then now, after the fact, it's been determined that not only am I dyslexic, I'm quite dyslexic. And fine, I became an engineer because of it, and more mathematically inclined, or not inclined. I went more on the theory side because you just deal with equations instead of all that reading. Uh, so it all worked out.
Yeah.
It, it,
And
it all worked out.
yeah. And I think it's an important, valuable story for everyone, whether they're dyslexic or they have another learning disability or any problem in general that is not considered like normal to everyone else. Like, that's not something that should stop you from anything. There's something out there that you will find that you love to do, and always just exploring, continuously being open to that is important for all of us to remember. And I'm a strong believer that, your background, the way you look, the way you identify yourself, none of that has to do anything with your job or like what you can do. So I think always just like you were saying, even though people didn't consider it normal, you still found something you love to do. You didn't give up, and you didn't be like, oh, okay, I can't do anything now. I can't, become a pilot, so I'm just going to stop. That, you were persistent, just important.
No, yeah, I would say, I guess, if there was a hurdle or a difficulty, and it's worse now than it was in my day, was just the expense of school.
Mm,
Um,
yeah.
that it was tough for my parents to afford it. So I had to go to junior college, and I had to work construction to pay for my education. And, you know, it, and keep a job while I was in school. But again, it all worked out. I would say in some regards, it taught me discipline because um, I had to do school on top of an income, a job that I was working to help pay for my education. Um, Given how expensive school is nowadays, I can imagine it's really hard to do that.
And it's always like, but the thing is that, really it's like something that everyone should take out of this interview is that you didn't stop, or you didn't like say, okay, I'm just not gonna go to college and I'm just gonna work now. And you were able to, just like push through your obstacles, and you didn't treat them really as obstacles, but rather things you should learn from, because the job experience probably helped you with time management, taught you many valuable life skills. And that's really important to also take into
Yeah.
perspective. And so kind of gearing a little bit away from your story, I'm curious about the future of the space industry in your eyes. What makes you excited and what makes you nervous about the future?
Well, excited about the future is we're growing more dependent on space all the time. You know, even if we weren't planning to go back to the moon and we weren't planning on going to Mars, we're becoming more reliant on a network of satellites to do everything. Tracking aircraft, the weather, communication, science, everything. So that is, and space is cool, again,
Yeah.
for a variety of reasons. So here at Rensselaer Polytechnic Institute, the second largest engineering program is Aero. None of the other programs are even close. The biggest is mechanical, the second largest is Aero, and all the others are, you know, distant third, fourth, and fifth. It's not even close. And then when you look in Aero, depending on the year, between 60% and 2/3 of the students are in space. So not just a majority, but a super majority of students are interested in space. So space is cool. I don't know whether we should thank Star Wars or the Martian movie or just whatever, or Elon Musk for what he's doing with SpaceX, but space is cool. So that's always fun when you're teaching, at least, and the students are all excited about the subject and they're glad to be there. It certainly makes my life easier. The double-edged sword associated with the fact that we're growing more a lot reliant on space takes me back to my personal research. You know, it makes me cringe when I hear about, you know, Amazon talking about putting 50,000 satellites up, or Elon Musk or others that are going to be putting up thousands of satellites. If those satellites start crashing into each other, it's amazing the mess that it will create. There's a phenomenon out there. It was proposed by Donald Kessler in 1977, now popularly called the Kessler Syndrome, when he was a scientist at NASA Jet Propulsion Laboratory. European Space Agency data indicates that it's begun. You know, we're on the shallow part of the curve, but it will be exponential growth, and you'll end up with an unstable runaway situation. And if something isn't done where we actively start reducing the amount of objects in space, you can end up with what's called a cascade of collisions, and large regions of space will become unusable. And I just wish more people were taking it seriously, because it's real. And again, European Space Agency data shows that it has begun, and it is following the model that Donald Kessler predicted. And so my great fear is that some countries won't pay attention to it until something really catastrophic happens. You know, there is a tendency by some not to do anything until something really, really, really awful happens. Unfortunately, at that time, it's too late in some regard. And so that's my fear. I think space is really, really great, but some of the players should have be more civic minded and more environmentally minded. And I don't mean just the environment here on Earth, but I mean the environment orbiting space. And we should do a little bit better job of cleaning up after ourselves.
Yeah, first off, I just have to address the fun part of, being in space. I think space is very cool. There's so many different jobs, and I feel like these days, space has been a lot more in the news with like commercialization of space industries, more private space companies starting up. It's no longer just government. I feel like that has increased traction in the news and social media. Everyone's like, "Oh, space, space," which is awesome to see, and like the future workforce, the future generations in space industry is very exciting. And yeah, the negative aspect of like the space debris, like you were mentioning, but also like collisions and of the objects that are in space. It's very scary to imagine it's already here and it's already happening. Something that we wanted to prevent is already happening, which I wasn't aware of. I think the main reason it happens is because lack of awareness. And even if it's like some people know about it, it's really hard to communicate that with the rest of the world until something really bad happens that catches everyone's attention, which is like really sad to think about, but something that we need to constantly raise awareness before something bad happens. Yeah.
Absolutely.
Yeah. And so, my last question for you to wrap up the interview is, what advice do you have for young people, which you kind of talked about during the interview, but regarding their pursuit of a passion, going into the space field, STEM field, really any industry at all, something you wish you knew when you were a younger student?
Well, that's good because I would say, and it's easier said than done, you should do your best to pursue your passion, because if you're excited about it, it's not work. It's really easy to get up and go to work in the morning if you don't view it as work, if you enjoy what you're doing. The reason it is easier said than done is oftentimes you're not quite sure what your passion is. You only think you know what your passion is. And so it's very possible that you could try getting into something like me. And once you get into it, you discover, this isn't what I thought it was. And so then you try making a turn, and then you're scared because you made this huge commitment and things didn't quite work out the way you thought. I guess to that, I would say you should still pursue your passion and don't be afraid of failure. Failure is a good thing as long as you, and I mean, failure, not the complete crash and burn, but oh, that was the wrong choice, just as long as you learn from it. Okay, yep, that I shouldn't have done that. I'm not going to do that next time. That it's okay to make a mistake as long as you learn from it. And if you make the mistake early before the consequences are very severe or costly. And so when that happens, learn from it and then be brave enough to make a turn if a turn is required. That's sort of what I did. That again, I thought I wanted to be a fighter pilot, and that wasn't going to work out. Then okay, well, I'm going to be in anthropology, and that didn't work out. Okay, I'm going to be an engineer. Well, that did work out to the point that even, my company at one point was going to recommend me to be a mission specialist on the space shuttle. At that point, though, I still couldn't pass the physical because my eyes had continued to decrease. We thought there was hope because you'll see that a lot of astronauts wear glasses nowadays. But interestingly, there's still pretty tight bounds on what they'll let you have. And at that point, I was getting old enough that I said, no, I'm not going to go through and do the LASIKs just for that. I'm happy to stay on the ground. So yeah, look for your passion. That's part of the adventure. That's part of the journey, as it were. Having said that, it is all right to do things that aren't your passion, but all I can say is if you're not passionate about it, I hope you're getting well paid for it. It is possible to be a mercenary and be perfectly happy being a mercenary because you're getting paid well. But I would say it's certainly still a lot easier going to work if, yeah, it's nice that you're getting paid, but you actually enjoy what you're doing.
Yeah. Yeah. I think that's amazing advice you give, Dr. Anderson. I think that's something that my parents have also, ever since I was a little kid, stressed. They would always put me in various activities, whether it be robotics, basketball, singing, art. Like they always made me explore because they're like, do something you love to do. Because I feel like they've always seen like if you like something, you do something you like to do, the money automatically comes. Like that's their philosophy. Because if you like something, you're not going to stress about the other factors and you're going to enjoy your life as well, which is like the ultimate thing you want to have. And so I think that's amazing advice for all of us. We should try finding our passion. And again, it ties back to the point, never limit yourself to trying new things. Always be open and explore new things. So I want to thank you so much, Dr. Anderson, for sharing your story and your amazing research and projects that you have and are currently working on. It's truly exciting. And, thank you for your time.
My pleasure. Thank you for inviting me.